Welcome back! I'm Luyren, and this is my Stencyl resource pack tutorial series, where I explain and showcase the resource packs I have developed for use in your Stencyl games. Check part 1 if you want to know what Stencyl is. Part 2. Luyren's RPG Elements Pack. The RPG Elements Pack handles character growth through statistics. These include experience, character status, combat statistics, damage type modifiers, status condition resistances, equipment, inventory, money, game difficulty, and skills list. They are all behind the scenes information, and you won't have much visual feedback once you configure everything. It takes a bit of effort to integrate all these elements into your game, but hopefully it will be worth it. These elements are included in my Cutscenes resource pack, where they have extra features and are integrated with the scripting system. This means that if you are using the Cutscene pack, you don't need to import the RPG elements separately. This pack is also compatible with the Miscellaneous Behaviors pack from the previous video. In this video, I'll explain how to customize each behavior, some of the results you can get with them, and how to incorporate them into your games. There might be discrepancies between this video and the version you have. You can follow along regardless, but always give priority to the description of the attributes of your version. As always, links to get all my resources will be in the description below. There are a few things worth explaining before we dive in. Whenever I refer to local values, those are the same as actual values. They work like regular attributes, not persisting through scene transitions. Global values, on the other hand, are the same as dynamic game attributes. They act as game attributes, persisting through scene transitions, but they do not need to be created under Settings attributes. Almost all behaviors have a global value attribute. It holds the name of a global value that stores all the attributes that need to be saved to keep the behavior state across scenes. In most cases, you can use the default values for your player actor. But that's not the only saving option. If you're using the Cutscene pack RPG variation or the Miscellaneous Behaviors pack, you can use the Save Status behavior. With that, you don't have to use the global value option described previously. You can see in each behavior's description a section called Attributes to Save. These are the attributes you can add to the Save Status behavior in order to save that information to it. In the case of the Cutscene pack version, its default values already contain all the necessary attributes to save for the RPG elements, with the exception of the inventory. That is because inventory is better handled by a global value, in case you have multiple player actors that share the same inventory. Debugging is mostly consistent across most behaviors. You have a boolean to activate or deactivate debug mode, and a starting position for the debug drawing on screen. Several behaviors will draw the debug information as a list, starting at the given position. Lastly, I recommend watching the first part of this tutorial series, at least its beginning, as it explains importing resource packs and behaviors. Now that we are all set, let's get started. Character status. This behavior defines as many character status as you want, and their progression with each level. These would be strength or dexterity in a tabletop RPG. You can partially configure the progression of each status, and have the behavior automatically generate the rest up to the maximum level. This also handles temporary and permanent status modifiers. In this behavior, saving stores the temporary and permanent modifiers, and the timer for each of the temporary modifiers. Number of modifier indexes is the number of temporary modifiers each status can have at once. Think of it as the number of sources of modifiers. If the actor can use a skill to increase strength, collect a pickup item to increase strength, and have a temporary story power-up, the actor would need 3 indexes for all those modifiers to be applied at once. Of note, equipment modifiers are not included in this count. They use their own indexes. The index count starts at 0, so if you have 3 modifier indexes, you have indexes 0, 1, and 2 available. The character status attribute is where you configure each of the statuses. You can have as many as you want. To create a new character status, set the key to the name of that status and its value to the following parameters, separated by slashes. Cap, the maximum value of that attribute, including all modifiers. Set this to no cap to not limit this status. Auto progression. This option automatically completes this status's level progression up to the maximum level. Maximum level is defined in the experience behavior. If you set this to arithmetic, the growth rate is added to this status every level. If you set this to geometric, the growth rate multiplies the previous value each level. Set this to none to not use an automatic progression. Growth rate, number used for the automatic progression. You can use decimal points here. Leave it as 0 if not using an auto progression. Values. This is the sequence of all the values for each level, separated by commas. This list starts with the first value for level 0, meaning you always need at least one number on this sequence. You can fill this list up to whatever level you want, and have the auto progression setting complete the rest. By checking the debug boolean, the behavior will draw all of these character statuses, their current total values, including all modifiers rounded, and their maximum values. It will also print in the log viewer or the game controller the full progression of each status as soon as this actor is created. The custom blocks are your way of interacting with the character's statuses. Get character status retrieves the total value of that status. Get value cap returns the maximum value for that status. Add permanent bonus adds a permanent bonus for that status. Use negative numbers for penalties. Add temporary modifier adds a temporary modifier to the given status. You select the modifier number, the status, the duration in seconds, and the index, as described in the number of modifier indexes attribute. The index -1 is used by the equipment behavior for their modifiers. It's the only index that can stack with itself if applied in succession. Remove temporary modifier removes one modifier index from the given status. You also have the clear temporary modifiers trigger, which removes all temporary modifiers for all status for the actor. Now that we got the behavior configured, how do you integrate it into your game, making use of those values and modifiers? Let's go over a few cases. In this example health behavior, I want to tie the maximum health to one of the character statuses. You can set your maximum health attribute to one of those status values using the custom block. The same can be done with a behavior that deals damage, for example. With a simple collision event, you can apply a temporary or permanent modifier to the character status as a pickup item. Be mindful of the collision groups to ensure that only your desired actors can collide with this power-up. In a buff type status condition, which makes your actor stronger, you can use a temporary modifier. If the buff is cancelled prematurely, use the remove modifier block. In the cutscene Restore Spec RPG variation, there are behaviors for item effects, and cutscene effects. That apply permanent or temporary status modifiers to actors. Combat statistics. This behavior allows you to create formulas for several combat statistics. While the character status behavior contains the base status per level, combat statistics can combine that with other values, such as equipment bonuses, creating specific operations for each one. Before configuring any combat statistics, you must retrieve all values using the formulas by configuring the values to retrieve map attribute. Set the key to a name used to reference it in the operations and its value with the following, separated by commas: the value's name, the behavior's name or value between square brackets for actor values, map::key for map values, list::index for lists, or a dash for numbers. The default values already cover all the default values from the character status and equipment modifiers. You can also use them as a reference to add new status or actor values. With all the values retrieved, you can now configure the actual combat statistics. Once again, a map attribute is used for it. Set the key to a name you can use to reference it in custom blocks, the value with the cap for that statistic, and the sequence of operations. Let's break one down as an example. Here, the key name is defense level. It is used with the custom block to retrieve that statistic's value. The value starts with 100 and a semicolon. That is the maximum value for that statistic. Set it to no cap to not have a value limit. Next is the first operation. It starts with 0 and a comma. This 0 is the index in a list where this operation's result is saved. We then have two values and an operator. The operator is what defines the operation. Each of these symbols corresponds to one operation. The values can be numbers or one of the following. One of the retrieved values by setting it to value, colon, and a key from the values to retrieve map. Or the result of a previous operation by setting it to index, colon, and the index number of a saved operation. In this example, the value level is divided by 2. The result is saved in index 0. Level is this actor's current level. We have a vertical bar, and the next operation precedes it. You can add as many vertical bars and operations as you need. The next operation divides the value vitality by 2, and the result is saved in index 1. The third operation adds up both indexes 0 and 1, the result of the previous operations, and saves it in index 0. You'll notice that we use index 0 and save the result of this operation in that same index. You can use an indexing operation and save the result in that same index, overwriting it. You only need to save in different indexes when you want to use the result of multiple operations. The final operation adds index 0 and the value armor together, saving it again in index 0. To finish the combat statistic, you need to finally set its value. You do so by typing set, a comma, and the final value. This final value can be a number, a retrieved value, or an index where you saved an operation result. In this example, this combat statistic is set to index 0. Debugging shows all the combat statistics, their values and maximum values as a list on screen. You have custom blocks to change a statistics cap, retrieve a statistics value, and retrieve a statistics cap. You use them to integrate them into your game the same way as the character status behavior, when setting values such as maximum health, defense, or damage this actor can deal. Damage type modifier. This behavior provides a custom block that can modify a number intended as damage based on its type. The concept of modifier indexes is the same as the character status behavior. Saving here stores permanent and temporary modifiers, as well as the timer for each temporary modifier. Each damage type is configured in a map attribute. The key is the name of the damage type, and its value is the percentage by which this damage type is modified. A value of 0 means it is not modified at all. A value of 50 means it is reduced by half. Values above 100 can end up healing the actor as damage absorption instead of damage. Finally, negative numbers will increase the incoming damage as a damage type weakness. You must configure every damage type available in your game, even if all their modifiers start at 0. Debugging shows all the damage types and their values as a list on screen. For triggers, it has clear temporary modifiers, which removes all temporary modifiers for all damage types. For custom blocks, you have temporary and permanent modifiers, as well as remove modifiers, which all work the same way as the character status behavior. Get damage type modifier returns the total damage modifier value of the given type. Lastly, modify damage modifies the damage from a given type by applying its percentage modifier. Let's go over an example of its usage. Consider this custom block for a health behavior. You input a number as damage and a text as a damage type, and it decrements the actor's health based on the incoming damage. To alter this code to account for damage type, just place your damage parameter inside the modify damage custom block. If you're using Stencyl's default health manager behavior and its custom block to deal damage, just add the modify damage custom block inside of it. Difficulty mode. This behavior allows you to change actor values and attributes, and even kill the actor based on the current difficulty. Difficulty is a setting that can be unique to this actor or global, which is applied to all actors using the same global value name. When you configure the difficulty global value name attribute, this means this actor will use that as its difficulty setting. By changing that global value, you can change the difficulty for all actors. Use the same name in this attribute for all actors. Whenever you set the difficulty, set the global value to the name of the difficulty you want. The actual changes per difficulty are configured in the difficulty settings map. Set the key to the difficulty name and its value with the attributes and actor values you want to change, separated by slashes. For each one, you have the following parameters separated by commas: behavior name, attribute internal name, index, and new value. You can replace behavior name with value between square brackets to set an actual value instead. Index can be list, index, if changing a list item, map, key, if changing a map key, or a dash if changing any other value type. You can kill the actor based on the difficulty setting instead of changing attributes. This happens in a when created event and works when using a global value difficulty. To use this, replace the attribute settings with the text kill between square brackets. Let's go over a few examples. On easy, the experience growth attribute from the experience behavior is set to 80. We'll cover experience soon, but just so you know, this lowers the required experience per level when using an automatic experience progression. Make this actor level up faster. It also adds to index 0 to the actor's inventory the item Elixir. Nothing is changed on normal difficulty. It might be good practice to always add all the difficulty levels as keys in this map, even if they don't change anything. On hard, the weapon slot of the actor's equipment is set to Broken Sword, and the max health attribute of the health behavior, which is a number, is set to 5. The kill option can be used to reduce the number of enemies on lower difficulties, for example. In this case, it's best to set it in the Spectre tab in the Scene Designer, unless you have entire enemy types exclusive to higher difficulties, that is. You have a custom block to change the difficulty for individual actors. This only works if the actor doesn't use the global difficulty. Equipment. This behavior manages what your actor has equipped and the properties of each equipment. You can define as many equipment slots and equipment types as you want. Saving here stores the equipment set for this actor. To configure the equipment slots, set a key in the equipment map attribute to the slot name and its value to the name of the equipment in that slot. If you want to define a slot but not have an initial equipment, you can name it something like empty or leave it blank. A word of caution: just because your actor has an item equipped doesn't mean it has said item in its inventory. When setting initial equipment, you may want to also add that in the initial inventory for the actor, in the inventory behavior. You can create actors to represent the equipment's graphics. They will follow your main actor and constantly switch to an animation with the same name as your main actor's animation. If the equipment doesn't have a matching animation, it will hide itself. This is a way to have your actor show different armor or weapons depending on the equipped item. To set that up, first you need to configure the equipment actor parameters map. Set the key to the equipment name and its value to the actor type to create, its X offset, and Y offset from this actor's position, separated by commas. Second, you need to create your equipment actors. You can see that the sword and the spear have one animation with the same name as one of the guards' animation. Here's the sprite sheet for both the guard and its equipment, and how their positions overlap. The X and Y offsets are the distances to make your sprites match as you want them to. Sword uses -8x and 0y offsets, while spear uses -17x and 0y offsets. Because you only use one set of X and Y offsets per equipment, it is highly recommended you have the same size for all animations within one actor type. Equipment properties is how you define what each piece of equipment does. You set the key to the equipment name and its value with a list of properties, each separated with a slash, and the properties parameters separated by commas. You can see in the attributes description or in the documentation the list of properties in detail, but let's quickly go over them. In value, you can modify an actor value that you define in the actor values list attribute. This attribute contains all the values you will be able to modify, and their default values when you have no equipment altering them. This is used for the equipment modifiers, such as a sword's power or an armor's defense. Weapon type sets an attribute, called weapon type, to the given text. You can retrieve said attribute if you want that as a condition for your code. Damage type also sets an attribute, called damage type here, that holds the damage type. You can retrieve that attribute whenever you deal damage to use the equipment's damage type. Here you can see the getter for both weapon type and damage type. Apply modifier applies a modifier to a character's status, damage type resistance, or status condition resistance. This modifier persists until the actor switches equipment. Self-status constantly calls a trigger while the item is equipped. If you set a status condition to be activated with a trigger, you use that here. For example, if you have a status condition that halves all the damage received, you'd put the trigger for that status condition here. If you're using the cutscene resource pack RPG variation, you have additional equipment properties for color swap, particles, actor aura, and after image. You also need to specify a default color mode to return to when you don't have any equipment that swaps color for your actors. If this properties list doesn't match what you have, you're using an older version of this pack. You can either re-download it or refer to the documentation and the description in your version. Those ought to work on your end. Debugging draws all the equipment slots and the item in each of them as a list on screen. The available custom blocks are: get equipment, returns the item equipped in the given slot; set equipment, changes the item equipped in the given slot; check equipment, returns true if a specific item is equipped on the given slot. The available triggers are Hide Equipment and Show Equipment, which hide and show the equipment actors respectively. Experience. This behavior allows your actor to gain experience points, keep track of its level, and manage skills it can learn as it levels up. There are also a few display options. Saving here holds the experience amount and the current level for this actor. The initial amount of experience points, level, and maximum levels are all customizable. You have two display styles using actors. The first is Gauge, which is the one being displayed right now. The display actor acts as a gauge, and its animation shows the progress from empty to full. Frame 0 is when the gauge is empty, and the last frame is when the gauge is full. You can have as many frames as you want, and should be set to not loop. The second style is Icon. The display actor is an icon, and the behavior can spawn multiples of them, each representing a certain amount of experience points. This only works properly if the amount of experience points for each level is always the same, which can be achieved if you use a fixed level progression. You can see in the in-game window that it always requires 10 more experience points to reach a new level, and each animation frame of the icon corresponds to 1 experience point. The display actor's position on screen is set by defining the origin in the x-axis, left or right, and the y-axis, top or bottom, and the number of pixels from the origin. Origin refers to the side of the screen. When using Gauge style, you only configure index 0. When using Icon style, you configure as many items as you want icons on screen. The number of frames attribute is automatically set by the behavior when the display actors are created. The only reason you'd configure this value is to know the frame to set for a gauge style display without creating the actual display. The frame to set is stored in the display frame attribute, which is set here. There are no uses for that in this resource pack, but it plays a role in my RPG platformer kit. I will cover that in a future video. Experience multiplier is a multiplier applied to the received experience. You can set this to a number or to the name of an actual value that can be used to multiply the received experience. This actor value can be changed in the equipment behavior, for example. You can see here that the default value of the multiplier without any equipment is 1. There might be uses for a multiplier of 0 at each developer's discretion. You can manually configure the required amount of experience points for each level in the required EXP list. Each index corresponds to the amount of total experience points to reach the next level. For example, on index 1, with a value of 10, you need 10 experience points to leave level 1 and reach level 2. In most cases, index 0 should be left at 0. You don't need to configure the same index number as the maximum level. At maximum level 10, you'd only need to configure up to index 9. There's also the option to automatically create a level progression. This auto-progression starts at the last value configured in the required EXP list. In Fixed, you always need the same amount of experience points to level up. In Arithmetic, the amount required is increased by experience growth every level. In geometric, the required experience is multiplied by the experience growth every level. When using geometric, the last value manually configured in the required EXP list cannot be 0. To configure the skills learned at each level, you configure the learn set map. Set the key to the level and its values to a list of skills learned at that level, separated by slashes. If you are using the Cutscene Resource Pack RPG variation, this map is configured a bit differently. To learn a skill, you add the word skill, a comma, and the skill name. To modify a charge level, add the word charge, the charge type name, and the amount to increase by, all separated by commas. Again, you use slashes to add multiple skills or charge levels. These next two display options are exclusive to the Cutscene Resource Pack. They create floating messages from this actor's center position when experience is gained or the actor levels up. Use the float message display actor for this, as it is already configured for this purpose. You configure the Y offset from this actor's center to create a float message and adjust its starting height, a font, and in the case of the level up, a text to display. Experience screen messages holds the messages to display on screen when the actors get experience and level up, in this order, separated by a vertical bar. These messages are called using the screen message behavior, which we will cover shortly. If you type in the words experience between square brackets for the experience award message, it will be replaced by the received experience. Likewise, level between square brackets is replaced by the current level on the level up message. Level up triggers are called for all behaviors when your actor levels up. If you have a trigger that fully heals your actor, it can be used here, for example. Lastly, there are a few options for drawing with this behavior. Before any drawing can be performed, make sure the Activate Drawing boolean is true. And you set the proper layer ID for your drawings. You also have to set a font other than Stencyl's default font for any text or attribute drawing to work. Otherwise, your game will crash with a null reference error. You can draw arbitrary text, attributes, and vertical or horizontal bars, representing the progress until level up. To configure each drawing, use the following parameters separated by commas. Drawing type can be vertical gauge, horizontal gauge, text, and attribute. Position. On actor makes the drawing relative to this actor's position. On screen makes it relative to the screen. Margin. If the text or attribute has its origin on the left or right side, use left for the gauge drawings. On the game window, you can see that the percentage on the right side of the screen and the current experience on the left are using right margin. The amount of experience to the next level is using left margin. Another way of understanding it is the side that will be constant as the drawing length increases. And last, the X origin and position, Y origin and position, which are just like the position of the experience display actor described earlier. Always use left and top origins when drawing on actor. You then have additional parameters depending on the drawing type. Both horizontal and vertical gauges have gauge border, gauge width, and gauge height in pixels. Attribute has font name, attribute name, and behavior name. You can add the optional parameter round at the end to round numbers. You can leave font name as a dash to not change it. Some useful attributes to draw are current level, current EXP, next level, and EXP percentage. Text has font name and text to draw. Again, you can set the font name to a dash to not change it. Outside the drawing list, you can configure the font and the colors used for all drawings. This font is overwritten if you select another font during the text and attribute drawings. The Award Experience custom block allows you to give experience points to specific actors. As for triggers, activate drawing and deactivate drawing. Activate or deactivate the drawings in the experience drawings list. Create HUD and kill HUD creates or kills the experience display actors. And level up forces the actor to level up. This is a new feature I added after recording the experience segment. Anytime the actor receives experience, it is added to a pool. This pool is drained over time and added to the player's current experience points. It is saved in the global value attribute, and it was also added as a default attribute in the save status behavior for the cutscene pack. To configure how this pool is drained, you set up the experience display speeds attribute with the following parameters separated by commas. Increment speed is the amount the pool is drained by each cycle. If you add a percentage sign after the number, the amount will be a percentage of the required experience to the next level. At 100%, the entire experience pool will be drained at once, at a limit of 1 level's worth of experience per cycle. Increase time is the number of visual frames between each cycle. You've seen 1% at 0 speed and 100% at 0 speed. So let's see increment time of 10 frames at a speed of 10%. You can also set specific sounds to play when the experience increases and decreases for each cycle. Speaking of decreasing experience, you can now use the minus sign in the Modify Experience custom block to remove experience points. They can only be reduced up to the amount required for the current level, meaning the actor cannot lose levels by doing this. For the experience drawings, you can draw the EXP pool attribute to show the experience pool. Font by name. This behavior contains a global custom block that returns a font, given its name. You don't have to attach it to anything, it just needs to exist in your game so you can make use of the custom block. Inventory. This handles the items this actor holds. You can specify an amount of item slots, maximum amount of items, and different maximum amounts for specific items. There are also options to have multiple stacks of the same item. Saving stores this actor's inventory. If your game has multiple actors that share an inventory, have them all use the same global value name. Configuring the inventory list allows you to give items to your actor when it is created. Fill each item with the item's name, a slash, and the item amount. By checking multi-stack, you can have multiple stacks of the same item. When one stack reaches its maximum amount, it will create a new stack. By checking Use Empty Slots, when you remove an item from the inventory, it will leave that slot empty. Maximum slots is the maximum amount of different stacks of items in the inventory. Set it to 0 to have unlimited slots. Maximum amount is the maximum amount in a stack of items applied to all items. Set it to 0 to not have a limit. You can set different maximum amounts for different items by configuring the maximum amount map. Set the key to the item name and its value to the desired maximum amount for that item. This can be used for special items such as keys, for example. Item database is a game attribute of type list that you must create under Settings, Attributes. This is the list of all items in the game. Whenever you use the sort trigger, the inventory is sorted based on this order. Item message is the message displayed using the screen message behavior when the actor gets an item. The words item and amount in the message, between square brackets, are replaced with the received item and the amount, respectively. Debug shows all the items in the actor's inventory as a list on screen. There is a variety of custom blocks to interact with the inventory. Add item adds an amount of an item to the actor's inventory. Remove item removes an amount of an item from the actor's inventory. Erase item remove all stacks of the given item name from the actor's inventory. Get amount returns the amount of an item in the actor's inventory. Get stacks returns the number of stacks of the item in the actor's inventory. Get item at index returns the item in the given position in the inventory. Check maximum amount returns true if the first stack of the item is at maximum amount in the actor's inventory. Inventory full returns true if all inventory slots contain an item. Get maximum capacity returns the maximum capacity of a given item for that actor. Switch items switches the position of two items in the inventory. You select indexes in the inventory list to switch positions. You also have the sort trigger, which sorts the inventory based on the item database. A simple way to create an item pickup is to have a collision event that adds the item to the last collided actor. If you are using the cutscene resource pack, the item pickup and events manager behavior can be used to create item pickups and cutscenes that add items to the actor's inventory. Money. This behavior handles money for this actor. Saving stores the money amount for this actor. Use the same global value name for all actors that share the same money pool. Configuring the current money attribute gives the actor an initial money amount. The maximum money attribute determines the maximum amount of money your actor can hold. If you leave it as 0, there is no maximum amount, and your actor will be able to carry as much money as it can obtain. Money multiplier works just like the experience multiplier in the experience behavior. For the display options, you can create an actor type to act as an icon, and you also set the position of the money value drawn on screen. For both, you configure the position with the same setup explained in other behaviors. Origin side, position, and margin. You can configure a screen message when money is received using the screen message behavior. Here, the word money between square brackets is replaced with the amount of money received. The available custom blocks are: Modify money. Modifies the money amount for this actor. You can use the minus sign to subtract. Multiply money. Multiplies the actor's money by the given amount. Divide money. Divides the actor's money by the given amount. The available triggers are Create HUD and Kill HUD. They work just like the ones in the experience behavior. They remove the icon actor and stop drawing the money value on screen. The money behavior also got a new feature after I recorded this tutorial. It is similar to the display speeds explained earlier in the experience behavior. The difference is that it's only a display number that is changing over time. Internally, the money amount is instantly changed when using the custom blocks. What is important to note is that the percentage option won't work if you don't set a maximum money amount. Resize menu window. This behavior holds a custom block that resizes an image using the 9slice method. You need to attach this behavior to any actor that can use its custom block. The miscellaneous pack contains a version of this for scene behaviors, while this one is used for actor behaviors. In this pack, it is required for some of the background options in the screen message behavior. Screen message. This behavior displays a message on screen for this actor. You can configure their position, how many you can display at once, their background options, time they'll stay on screen, and the way new messages are organized in the stack. The experience, inventory, money, and use skill behaviors have options to display screen messages. The Messages Enabled boolean determines if this actor can display new messages or not. This can be changed with the Enable Messages and Disable Messages triggers. In the Message Positions list, you configure the position of each message slot. The number of items in this list is the maximum number of simultaneous messages on screen. Each item is configured with the same display options described in the experience and money behaviors: X origin, X position, Y origin, Y position, margin. New message style determines how new messages are added to the stack. End means they are added to the next available message position. Beginning means it is added to the first position, pushing all others. Excess message style determines what happens with the messages that are beyond the available number of positions. Remove means any excess messages are removed from the display. Store means the excess messages are stored and will be displayed once the positions are available. Display duration determines the time in seconds each message stays on screen. Each message has its own timer, and messages beyond the available positions do not count their timers until they appear on screen. There are a few background options. The actor options will create an actor, use the background box image attribute as its animation name, and use that as the background for each message. The image options will do the same, but background box image will be the name of an image file in the actors folder. Resize will resize the image to the given dimension. And variable will resize the image based on the length of the message. Both require the resize menu window behavior. Finally, box fixed draws a box of a solid color as the background, and box variable do the same with the variable width. Background margin are the distances of the background from the message in the order top, bottom, left, and right. Here you can see a value of 3 on all sides for the background margin. And here a margin of 0 on all sides. Finally, background color is used for the box options. This style of background is also used in the dialog interface and display options actor behaviors of the cutscene pack, which will be explained in a later video. The screen message custom block calls a message using these behavior settings for the given actor. As for triggers, stop display removes all messages from the screen. Enable messages allows this actor to display new messages. And disable messages disables new messages for this actor. Let's go over a few configurations. This is the one being used throughout this video. It has 3 display positions on the bottom left corner of the screen. New messages are added to the first position on the list, and any excess messages are automatically removed from the stack. This is based on games such as Castlevania: Aria of Sorrow. If we just change the new message style to end and excess message style to store, you get this. New messages are added to the last position on the list, and any excess messages will still be displayed after positions become available. The last style has only one position at the top of the screen. New messages are added to the last position on the list. Since there is only one position, any new message will be considered excess automatically. And as you can see, excess messages will be stored, and their timer will only count when they appear on screen. This is based on the messages in Secret of Mana from Super Nintendo. Status Condition Manager. This behavior organizes the status conditions this actor can be afflicted by, as well as the status resistance values for each one. This behavior doesn't handle the status condition effects, it only organizes them, so you can have a centralized place to determine the status conditions affecting this actor. The modifier indexes are the same as the character status and damage type modifier behaviors. Saving stores the temporary and permanent modifiers, and the timer for each of the temporary modifiers. The status resistance map holds the information for all the status conditions in your game. Set the key to the status name and its value to the following parameters separated by commas. Resistance. This is the resistance percentage for this status condition. Attribute internal name. Name of the Boolean attribute that is true when this actor is under this status condition. Behavior name. Name of the behavior to retrieve the Boolean from, that also has the effects of the given status condition. Let's look at the poison key as an example, from the default values. It has a resistance of 0, and it assumes there exists a behavior called status condition poison, with a Boolean with an internal name of _poison, that is true when the actor is poisoned. Debugging draws on screen all the status conditions, their resistance values, and if the actor is afflicted by them. The custom blocks are similar to the other behaviors. Return status condition resistance returns the total resistance against the given status. You also have add permanent and temporary bonuses, and remove temporary bonuses. Unique to this behavior is the suffer status condition custom block that returns true if the actor is suffering from the given status condition. This is a centralized way to check for that. You also have the clear temporary modifiers trigger to remove all temporary modifiers. Let's look at a way to integrate this into your own status conditions. Say we have a behavior for a poison condition. Create a trigger that is used to start this condition and place all the code inside an if statement. Check if a random number between 0 and 100 is greater than that status resistance, and if it is, execute the rest of the code. The actual effects on a poisoned actor can be handled in an update event. Use skill. This behavior manages the skills this actor knows, and you can cycle through a list of active skills. There are custom blocks to teach skills and make your actor forget skills. Saving here stores the list of known skills for this actor. By checking the use controls boolean and configuring the move forward and move backward attributes, you can cycle through a list of active skills. The give control and remove control triggers can change this. Current item is the index in the usable skills list with the name of the initial active skill you want to set for your actor. Known skills is the list containing all the skills this actor knows. By adding skill names to this list, you'll be configuring the initial skill set for your actor. Usable skills is the list containing all the skills this actor can actively use. When cycling through the skills, only those in this list will be displayed. This is used to differentiate between active and passive skills, which don't need activation to be used. As you can see, Magic Piercer and Double Flight are not in the usable skills list, meaning they won't show up when you cycle through the skills. The display can create an actor and draw the skill name on screen. You can opt to have only one of these display options by checking the corresponding booleans. The positions are configured just like in the money and experience behaviors. And as you can see, the icon can be animated. You also configure a specific animation name for your icon actor when no skill is selected. This is used if the actor has no active skills. As for the animation for the skills, the icon must have one animation for each of the active skills. Lastly, skill message is the screen message shown when the actor learns a skill. The word skill between square brackets is replaced by the name of the skill the actor just learned. For custom blocks, you have forget skill, makes the actor forget a skill. Teach skill, teaches a skill to the actor. Has skill, returns true if the actor has the given skill. The available triggers are Give Control and Remove Control, enable and disable player control to cycle through the active skills, respectively. Skill Forward and Skill Backward, move forward or backward in the active skills list. Create HUD and Kill HUD, which work just like the experience and money behaviors. They create and kill the icon and skill drawings on screen. When you want to check the active skill for your actor, the one you can cycle through, retrieve the attribute Skill Slot, like this. The Cutscene Resource Pack RPG variation has exclusive item effects and cutscene events to teach or make your actor forget skills. That covers everything for the RPG Elements pack. As a reminder, this can also be used as reference for my Cutscene Resource Pack RPG variation. Links to get this and all my other Stencyl resources will be in the description below. You can leave your questions in the comment section, on the Stencyl forums, or on the Stencyl Discord server. You can also reach me on Twitter, where I post updates about my ongoing projects. I'll be working next on the map system tutorial. If you're looking into making Metroidvanias with Stencyl, look forward to that. That is all. Thanks for watching.